Algebra 2 students, this is a review of lesson 5.1 in graphing quadratic functions. So this is a review. There's some new material in here that you won't find in your packet that I think you'll find very helpful as far as graphing these go. First of all, just general things about a quadratic. The greatest exponent of a quadratic, is 2. So when we see x to the second power or 3x to the second power, we know that this is a quadratic equation. The general form for a quadratic function is f of x equals ax squared plus bx plus c. This ax squared is called the quadratic term. The bx part is the linear term, as we've already studied linear functions, and the c value is the constant. Just some terminology there. The graph of the quadratic is a parabola, which we know is U-shaped. Some important parts of this parabola, this point here is the vertex. You can see it goes up from there, so we would also call this the minimum value, which would be the y-coordinate of that vertex. And then we also have an axis of symmetry that will run right down the middle of this parabola. So this is called the axis of symmetry. Now, graphing quadratics in general form. So general form is y equals ax squared plus bx plus c. Some important parts about this is the y-intercept is c. So the parabola will cross the y-axis at the constant, which is the c value. The axis of symmetry, the line that runs right down the middle of it, it's a vertical line, so it's x equals negative b over 2a. Negative b also meaning the opposite of b divided by 2a. The x-coordinate of the vertex is negative b over 2a. So if we're finding the vertex, the x-coordinate is the negative b over 2a. And then to get the y-coordinate, we're going to need to plug that x-coordinate in for x to get y. Now, this is something I think will be very helpful. It kind of eliminates making the table of values, which I think is good practice to start out with. But anytime from the vertex, to get other points, you can also go over 1 up whatever the a value is, then over 1 up 3 times the a, over 1 up 5 times the a, and so on. And so, for example, if you had an equation like this, you would find the vertex. Again, the x-coordinate would be negative b over 2a, so the x-coordinate would be 1. If I plug 1 in there, I believe I get negative 7. All right, and then from that vertex, we're going to go over 1 up a, which is 2, then over 1 up 3 times a, which is 6, then over 1 up 5 times a, which is 10. So looking at this graph a little closer, we've got the point 1, negative 7 being our vertex. And then I could go over 1 and up 2 on each side because of symmetry. And you can see now my y-intercept is negative 5. And then from there, I would go over 1 and up 6. And then I would have the general shape of the parabola. So when you're making your table of values, we could put our vertex right there in the middle of, sorry, that's a positive 1. -7, and then as we go over 1, we're going to go up 2. And as we go over 1, we're going to go up 6, and so on. And then we'd go up 10. Going the other direction, we would do the same thing because we've got symmetry. So kind of a quick and easy way of getting other points and not having to make a table of values. So here's a couple other examples. This one here, we've got the function x squared minus 4x plus 3. So I'm going to work to graph this one. I know my y-intercept is the constant, that is c. To get my vertex, it's negative b, so positive 4 over 2, which is 2. Plugging 2 in, so I've got 2 squared, which is 4, minus 4 times 2, plus the 3 is negative 1. So then I would have the point 2, negative 1 as my vertex. And then I would know my a value is 1 here. So I'm going to go over 1 up 1, then over 1 up 3a, which would be 3, then over 1 up 5. So I would have over 1 up 1 on each side, and then over 1 up 3. You can see that is my y-intercept. And my next move would be over 1 up 5. And this would be the parabola. Making that table of values, I put my vertex right there in the middle. I know as I go over 1, I would need to go up 1. As I go over 1, I'd go up 3. As I go over 1, I'd go up 5. And so this, again, kind of an easy way of getting some other points instead of having to plug in each time. The next function here, negative 5x squared minus 10x plus 6. You can see my y-intercept would be 6. Vertex, negative b, would be positive 10 over 2a, which would be negative 10. So that x coordinate would be a negative 1. If I plug a negative 1 in, make sure you realize that you square that first. Using parentheses is always helpful. So we'd have negative 1 squared is positive 1, that'd be negative 5, plus the 10, plus 6, which would be 11. So now I know my vertex is at a negative 1, 11. I'm stretching this out a little bit. Sorry about that. And then my a value is a negative 5, so I'm going to go over 1, down 5. My next one will be over 1, down 15. So from this vertex, if I go over 1, down 5, you can see that I would be at 6, which is the y-intercept. And then I'd have symmetry. And my next movement would be over 1, down 15. I'd be way down here at negative 9. And my parabola would look like this. Having a maximum value because of the high point there. So here's another practice. This is from the 5.1 practice. So if I would graph this one, I would know my y-intercept would be a positive 1. Why? Because it's my c value. My vertex would be negative b, which is 2, over 2a, which is 4. So you can see I do get a x-coordinate of 1/2. Plugging that in, I'm going to have 1/2 squared, which is 1/4. That's going to be a half minus 1 plus 1. So this is still going to be a half. Now, obviously we're going to have some fractions here, but just to show you, if I would use that method, if I have a half, this would be my vertex. And my a value is 2. So from there I'd go over 1 up 2, over 1 up 6, over 1 up 10. Now as we go over 1, we're going to go over to a half. And then I would just go up 2 values. Same thing over here, it'd be symmetrical. My parabola would look like this. All right, then the last part of the 5.1 practice. I believe we understood this pretty well here. But in number 8, you can see the a value is a -1, which means this parabola opens downward. So I know I'm going to have a maximum value. Remember that maximum value occurs at the vertex. In this case, my vertex would be doing -b over 2a. This would be -4 over a -2, which is 2. Plugging the 2 in, again I square the 2, make it negative, so it's -4. Plus the 8 would be +4, minus 1 would be 3. And so therefore we would say the maximum value of this function is 3. If I was to graph this, I'd have the point 2, 3, which is my vertex. Since my a value is a -1, I'd go over 1 down 1, then over 1 down 3, then over 1 down 5. So over 1 down 1 puts me right there. If I go over 1 down 3 now, 1, 2, 3, you can see I'm right on my y-intercept, which is -1. Using symmetry, the graph would look like this. And in our next lesson, remember, we're going to be starting to talk about the zeros of these, where it crosses the x-axis.